Good morning to all of you. I hope I am audible and my screen is visible to you. Before starting today's class, let me just give you a brief recap of what we have done in the previous class. In the previous class, we have solved few problems related to Dalembert's principle. That is, we have solved this problem, the problem which you can see in my screen. This problem we have solved in the last class, as well as we have solved this inclined plane problem also. In today's class, we will solve two more problems related to Dalembert's principle, and after that we will wrap up this module of Dalembert's principle, and then in the next class we will start with a fresh module. So we will not waste any more time. In continuation with the problems that we were solving in Dalembert's principle, the next series of problem that we will be solving in today's class is this problem number 7. So let me read out the problem for you. The problem is two blocks A and B are kept on an inclined plane 5 meter apart as shown in the figure. So you can see there is an inclined plane whose angle of inclination is 20 degree. On this inclined plane, two blocks are kept. One block is your block A and the second block is your block B. And in the problem it has been told to you that both the blocks are separated. Both the blocks are separated by a distance of 5 meter. What else is given in the problem? The coefficient of friction between the block A and B and the inclined planes are 0.2 and 0.1 respectively. That means coefficient of friction present between block A and this inclined plane surface is how much? It is 0.2, as well as the coefficient of friction present between the contacting surface of block B and the inclined plane is how much? 0.1. So if I assume coefficient of friction at the contacting point for block A by mu A and coefficient of friction at the contacting point for block B by mu B, then what is given in the problem? According to problem, mu A is 0.2 and mu B is how much? Mu B is 0.1. If the block begins to slide down the plane simultaneously, calculate the time and distance travelled by each block before collision. Now what is happening? Block A is released down the inclined plane, as well as block B is also released down the inclined plane. So when you release block A and B down the inclined plane, what will happen? This is the end point of the inclined plane. At this end point, both block A as well as block B will collide with each other. I repeat, when you release block A and block B simultaneously, then after some period of time down the inclined plane, that is, this is the position, at this position both the two blocks will collide with each other. What you need to find out? You need to find out the time and distance travelled by each block before collision. Before collision, how much distance travelled by block A as well as how much distance travelled by block B. Say suppose both the two blocks collide over here, at this point both the two blocks collide. Before collision, distance traveled by block A from its initial position to the colliding position is how much? SA. And say suppose the distance traveled by block B from its initial position to the colliding position is how much? SB. So how much is SA? That you need to find out, and how much is SB? That you need to find out. What are SA and SB? SA and SB are the distances traveled by block A and block B separately before collision. This is the first part of the problem that you need to find out. And what is the second part of the problem? In the second part of the problem, you need to find out time taken by each block before collision. That means before colliding, how much time taken by block A to reach to this colliding point, and how much time taken by block B to reach to this colliding point. This we need to find out. Is it clear to all of you? I hope it is clear. Say suppose the time required or time taken by both the block to reach to the colliding point is denoted by T. Okay. Say suppose time taken by both the block to reach to the colliding point is how much? T. So how much time both the two blocks have taken to reach to the colliding point, that you need to find out. That means in this problem, this time T we need to find out, as well as how much distance both the block will travel before colliding. Say suppose SA is how much? SA is what? SA is the distance traveled by block A before colliding. And what is SB? SB is the distance traveled by block B before colliding. And from the diagram it is clear that from the initial position of block A to the final colliding position, distance traveled by block A is how much? SA. Similarly, in the diagram it is given that from the initial position of block B to the final colliding position, distance traveled by block B is how much? SB. Given in the problem. So how much is SA and SB? This we need to find out, as well as how much time taken by both the block to reach to the colliding point. Before collision, how much time both the block has taken to reach to the colliding point, that we need to find out. That is time T we need to find out. I hope this problem is clear to you. You might have understood the problem. Now let us solve the problem. How we can solve this problem? So first of all, what we need to do? We need to draw the free body diagram of both the two blocks separately. So let us draw the free body diagram of both the two blocks separately. So for block A, what all forces are acting on this block A? One force is the weight of the block that will act vertically downward, and that weight is how much? Mg. Say suppose mass of the block is Ma into acceleration due to gravity is G. Okay, this is that Mg, M suffix A into G. M suffix A represent mass of the block A. Now this block A is kept on this inclined plane. So this inclined plane will give a reaction to this block A in vertically opposite direction. So this is the reaction force that the inclined plane surface will provide to this block A. Let that reaction force is denoted by symbol RA. This is that reaction force RA. Okay. Now from the problem it is very much clear that block A is moving down the inclined plane. Block A is moving down the inclined plane. That means for block A, direction of motion of the block A is in this direction. Block is moving down the inclined plane. Okay, so if the block is moving down the inclined plane, there will exist a frictional force at the contacting surface of block A and the inclined plane, because the inclined plane is rough, it is not smooth, and that frictional force will act in the direction opposite to the direction of motion of the block A. So block A is moving down the inclined plane, so frictional force at the point of contact will act in up the inclined plane, and its magnitude will be how much? Its magnitude will be mu A into normal reaction which the inclined plane surface is giving to the block A, that is RA. Mu A into RA. Okay, next is, now by geometry you see, if this angle is 20 degree, then this angle will also be 20 degree, and if this angle is 20 degree, then this MAG will have two component. One component will be MAG cos 20, this component will be MAG cos 20. I am writing cos 20 as C20, and this component will be MAG sin 20. MAG sin 20. Okay, you can see this component is your MAG cos 20, that is this component is your MAG cos 20, and this component is your MAG sin 20. Clear? Okay. Is the FBD of block A complete? Or whether I have completed the free body diagram of block A? No, it has not been completed. Why? Because we have not considered the inertia force into account. Since the block A is moving down the inclined plane, so the inertia force will act up the inclined plane in order to keep the block A in dynamic equilibrium. So this is the inertia force direction, and its magnitude will be how much? Its magnitude will be mass of the block A into acceleration of block A. So mass of the block A is denoted by MA into acceleration of block A is denoted by small a suffix capital A. This is the inertia force that will act on this block A, but this inertia force will act up the inclined plane. Why? Because the motion of block A is down the inclined plane. Now is the FBD of block A is completed? Yes, now the entire FBD of block A is completed. Similarly, let us draw the FBD of block B. So what all forces are acting on block B? The first force is the weight of the block B, that is acting vertically downward, that is WB, and WB is nothing but mass of the block B into acceleration due to gravity G. Block B is in contact with the inclined plane surface. So this inclined plane surface will give a reaction to the block B, and that reaction will be vertically opposite to the surface. So this surface is like this. This is the inclined plane surface. So reaction force will act like this at an angle of 90 degree to the surface, and let this reaction force is denoted by RB. Okay, Now by geometry, if this angle is 20 degree, then this angle is also 20. If this angle is 20 degree, then MBG will have two component. One component will be MBG cos 20 and one component will be MBG sin 20. So this component is your MBG cos 20. This component is your MBG cos 20 and this component is your MBG sin 20. MBG sin 20, correct? Since the inclined plane surface is rough, so at the point of contact of block B and the inclined plane surface, frictional force will act, and the direction of frictional force will be in the opposite direction to the direction of motion of block B. And from the diagram or from the problem, it is very much clear that block B is moving down the inclined plane. So this is the direction of motion for block B, correct? So if the block B is moving down the inclined plane, frictional force at the contacting point will act up the inclined plane and its magnitude will be mu B. Mu B is what? Mu B is coefficient of friction at the contacting surface of block B and inclined plane into normal reaction which the inclined plane is giving to the block B, that is RB. Is the FBD of block B is complete? No, FBD of block B is not completed yet. Why? Because we have not considered inertia force into account. In order to keep the block B in dynamic equilibrium, according to Dalembert's principle, we need to add one inertia force, and I know that the direction of inertia force acts in the direction opposite to the direction of motion of the block. Since block B is moving down the inclined plane, so inertia force on the block B will act up the inclined plane. And what will be the magnitude of this inertia force? Its magnitude will be mass of the block, that is mb, into acceleration of the block, that is a suffix b. Now is the FBD of my block B is completed? Yes, now the FBD of block B is completed. You can see in the diagram, this is the FBD of block B. Whatever I have drawn just now for block B over here, the same diagram is this one. But remember one thing, in this problem, acceleration of block A and B will not be same. I repeat, in this problem, acceleration of block A and block B will not be same. Why it is not same? Since A and B are not connected by any common string, fine. That is why the acceleration of both A and B will not be same. And we have also not given the masses of block A and B. How much is the mass of block A? How much is the mass of block B? It is not given. Block A is kept at a distance SA from the colliding point, whereas block B is kept at a distance SB from the colliding point. Fine. So SA will reach first at the colliding point and then the SB block will reach. So remember one thing, that in this problem acceleration of both the two blocks will never be same. So that is why for block A I have written acceleration of block A as small a suffix capital A and acceleration for block B as A suffix capital B. If the free body diagram of this problem is clear to all of you, I hope it is clear. Now let us solve the problem. So how we can solve it? We need to write down the force equilibrium equations for both the block separately. Fine. So first of all, let us write down force equilibrium equation for block A. So for block A, we are writing down summation fx is equal to 0. So what we can write down? We can write mag sine 20. Okay, let us assume that on this, since this is your inclined plane, let us assume that this side x is positive, this side x is negative, this side y is positive, and this side y is negative. So if I write summation fx equal to 0 for block A, what will be the equation? Equation will be mag sine 20, mag sine 20, okay, minus frictional force, that is minus mu A into Ra, minus this inertia force for block A, that is minus ma into Aa. No other forces are present along x direction, so it is equal to 0. So finally what I am getting, summation fx is equal to 0 is mag sine 20 minus mu a Ra minus ma equal to 0. ma into Aa, take it on the right hand side, equation will be mag sine 20 minus 0.2 Ra equal to ma into Aa. That is equation number 1. Similarly, let us write down force equilibrium equation along y-axis for block A. That is summation fy is equal to 0. What we will get? Summation fy equal to 0. We have assumed this y as positive and this y as negative. So equation will be Ra acting in positive y direction minus mag cos 20 acting in negative y direction minus mag cos 20. No other forces are present along y direction, so it will be equal to 0. Or if you take mag cos 20 in the right hand side, what you will get? You will get Ra is equal to mag cos 20. That is this equation. Now what we will do is we will substitute the value of Ra, which is mag cos 20, in equation number 1. Let us substitute it. What we will get? We will get equation number 1 as mag sine 20 minus 0.2 into Ra. Ra is how much? Ra is mag cos 20. mag cos 20 equal to ma into Aa. Now from this equation, which equation? From this equation, let us take ma common. When you take ma common, what you will be left out with? In bracket you will get g sine 20 minus 0.2 into g cos 20, bracket close, into ma is equal to ma into Aa. Now this ma and ma will get cancelled out. Finally you will get AA as how much? G sine 20 minus 0.2 G cos 20. What is G? G is your acceleration due to gravity and its magnitude is 9.81. So we will get 9.81 into sine 20 minus 0.2 into 9.81 into cos 20 equal to AA, and if you solve it you will get the acceleration with which block A is moving down the inclined plane. So block A is moving down the inclined plane with how much acceleration? With 1.511 meter per second square. So far what we have found out? We have found out that when the block A is moving down the inclined plane with acceleration equal to 1.511 meter per second square. Similarly, for block B, let us write down force equilibrium equation, and from that force equilibrium equation let us try to find out what is the acceleration with which block B is moving down the inclined plane. So first let us write down summation fx equal to 0 for block B, summation fx equal to 0 for block B. What we will get for block B? If I write summation fx equal to 0, we have assumed this x as positive and we have assumed this x as negative. So we will get this mbg sine 20, that is mbg sine 20, okay, minus mb into ab, inertia force, minus mb into ab, inertia force, minus this frictional force, minus frictional force, that is mu b into rb. No other forces are present along x direction, so it will be equal to 0. So what we are having? We are having mbg sine 20 minus mu b rb minus mb into ab is equal to 0. That is this equation. This equation. In this equation, bring mb into ab on the right hand side. So finally you will get mb into g sine 20 minus mu b is given in the question, that is coefficient of friction between the contacting surface of block B and the inclined plane. That is how much? That is 0.1. So mu b is 0.1 times of rb equal to mb into ab. So this is your say equation number 2. This is your say equation number 2. Similarly, let us write down summation fy equal to 0 for block B. Let us write down summation fy equal to 0 for block B. So for block B, if I write down summation fy equal to 0, we have assumed this side y as positive and this side y as negative. So we will get RB acting in positive y direction minus MBG cos 20 acting in negative y direction minus MBG cos 20. No other forces are present along y direction, so equal to 0. Or finally you will get RB is equal to how much? RB will be equal to MBG cos 20. Finally you will get RB equal to MBG cos 20. Now what we will do is we will substitute the value of RB, which is MBG cos 20, in equation number 2. What we will get? We will get MBG sin 20 minus 0.1 into RB. RB is how much? RB is MBG cos 20 equal to MB into AB. Okay. Now MB is cancelled out. This MB, this MB and this MB is cancelled out. Finally, we will be left out with G sin 20 minus 0.1 into G cos 20 equal to AB. What is G? G is acceleration due to gravity. Its value is 9.81. Just substitute the value of G and solve this expression. Once we solve this expression, we will get the value AB. What is AB? AB is the acceleration with which block B is moving down the inclined plane. So block B is moving with acceleration of 2.43 meter per second square. So far what we have found out in this problem? So far, by writing down the force equilibrium equation for both block A and block B, we have found out the acceleration with which block A and B will move down the inclined plane. That is, acceleration of block A is how much? Acceleration of block A is 1.511 meter per second square, and acceleration of block B is how much? Acceleration of block B is 2.43 meter per second square. But actually what we need to find out in this problem, we need to find out firstly how much distance covered by block A and block B before colliding. So from the diagram it is very much clear that distance covered by block A from its initial position to the colliding position is how much? SA, and distance travelled by block B from its initial position to the colliding position is how much? SB. So this SA and SB we need to find out. How we can find out SA and SB? For that we need to write down the equation of motion. Which equation of motion? Second equation of motion. And the second equation of motion is S is equal to UT plus half AT square, in which S is what? S is the distance travelled by the body, U is the initial velocity of the body, T is the time taken by the body to complete distance S, and what is small a? Small a is acceleration of that body. So we will write down separately the equation of motion, second equation of motion for block A separately and for block B separately, and then from that equation of motion we will find out SA and SB. So let us write down equation of motion for block B first. Let us write down equation of motion for block B first. So for block B, what is the equation of motion? Equation of motion is S. S means distance covered or distance travelled by block B. Distance travelled by block B. Distance travelled by block B till the colliding point is how much? SB. So SB is equal to U is initial velocity of block B. So initially in the problem block B is not given any kind of velocity, so it will be 0. So SB is equal to U into T is time taken by block B to reach to the colliding point plus half AT square. Half into A means acceleration of block B. Acceleration of block B is AB into T square. T means time taken by block B to reach to the colliding point. So the equation of motion for block B becomes SB is equal to half AB into T square. Okay, AB just now we have found out by writing down the force equilibrium equation for block B. just substitute the value of AB in this equation. SV equal to half AB T square. What we will get? We will get SB, that is SB is equal to half into AB. AB is how much? AB is 2.43. This is your AB, 2.43 meter per second square. So half into in bracket 2.43 into T square. Let this is equation number 3. Similarly, for this block, for block A, again we will write down equation of motion, second equation of motion for block A. So for block A, second equation of motion is S is equal to UT plus half AT square. S means distance travelled by block A from its initial position to the colliding position, and from the diagram that distance is how much? SA is equal to U into T. What is U? U is initial velocity. Since in the problem block A is not given any kind of initial velocity, so U is 0 for block A, into T is time taken by block A to reach to the colliding point, that is T, plus half times of AT square. A is what? Acceleration of block A, and acceleration of block A is A suffix A into T square. T square is, what is T? T is time taken by block A to reach to the colliding point. So finally the equation will be SA is equal to half AA into T square. In this equation, what we know? We know the value of AA, that is acceleration of block A. Just now we have found out the acceleration of block A by writing down the force equilibrium equation for block A. So just substitute the value of acceleration of block A, that is 1.511 meter per second square, in this equation. Which equation? This equation. So let us find out what we will be left out with. We will be left out with SA is equal to 0 into T is 0 plus half into AA. AA is 1.511 into T square. Let this is equation number 4. So we have written down the distance travelled by block B, that is equation number 3, half times of 2.43 into T square, and distance travelled by block A, that is SA is equal to half times of 1.511 into T square. Now we need to find out SB and SA. How we can find out? For that, again you see the diagram of the problem. From the diagram it is very much clear that SB, this is my SB, SB will be equal to how much? SA, from here to here, this distance is SA, plus distance between block A and block B is how much? 5 meter, plus 5. Yes or no? Can we write like this? Yes, we can write. If you see the diagram, from the diagram it is very much clear that SB, that is distance travelled by block B before colliding, is equal to SA, distance travelled by block A before colliding, plus intermediate distance between block A and block B, that is 5 meter. Or I can write SB is equal to SA plus 5. Or I can write it as SB minus SA is equal to 5. Now in this equation, let us substitute the value of SB and SA. So value of SB is half times of 2.43 into T square, and value of SA is half times of 1.511 into T square. So let us substitute these values. we will get SB as half times of 2.43 into t square minus SA as half times of 1.511 into t square is equal to 5. Let us solve it. 2.43 by 2 is how much? 1.215 t square minus half times of 1.511 is how much? 0.755. T square is equal to 5. Or I can write 1.215 t square minus 0.755 t square is how much? It is 0.4595 t square is equal to 5. Or t will be equal to how much? T will be equal to under root of 5 by 0.4595. 0.4595. If you solve it, you will get the value of t, and that t is how much? That t is 3.298 seconds. That means both block B as well as block A will take 3.298 seconds to reach to the colliding point. I repeat, both block A and block B will take how much time? Will take 3.298 seconds of time to reach to this colliding point. This was the first part of the problem that was asked to you in this question that we have found out. That is how much time both the block will take to reach to the colliding point. That is 3.298 seconds. First part of the problem is solved. Second part is we need to calculate distance travelled by block A, which is SA, and distance travelled by block B, which is SB, before collision. So how we can find out? We have the equation of SB and SA. Equation of SB is how much? Equation of SB is nothing but equation number 3, that is half times of 2.43 t square, and equation of SA is how much? Equation of SA is denoted by equation number 4, that is SA is equal to half times of 1.511 times of t square. T just now we have calculated, so just substitute the value of t in the equation of SB and SA. We will get the value of SB and SA. So SA is how much? SA is half times of 1.511 into t square. T is how much? 3.298 whole square. If you solve it, you will get SA as 8.22 meter, and distance travelled by block B is how much? SB is equal to half times of equation number 3, that is 2.43 into t square. 2.43 into t square. T is how much? 3.298 square. If you solve this expression, you will get the value of SB. SB is how much? SB is 13.21 meter. That means block A will travel a distance of 8.22 meter and block B will travel a distance of 13.21 meter before colliding with each other at the colliding point. This is the second part of the question which was asked to you. I hope this problem is clear to all of you. Okay. Next, now let us solve the last problem of Dalembert's principle. After this problem, we will wind up this module of Dalembert's principle. What is the problem? The problem is a block weighing 40 Newton is accelerated along the horizontal plane by means of a 20 Newton weight attached to it through a flexible, inextensible and weightless rope passing over a smooth pulley as shown in the figure. That means, according to this problem, there is a block. This is a block, and this block is accelerated horizontally by the help of this weight, which is attached with this pulley through this frictionless rope. That means this weight is moving down. Then only this block will be accelerated in this direction. Again I repeat, according to this problem, what is given to you? There is a block which is kept on a horizontal surface. This is your horizontal surface. Okay. This block is connected by a weight. This is your weight through a string, inextensible string passing over a pulley. Okay, and in the problem it has been told to you that this block is given a horizontal acceleration. How this horizontal acceleration you can give to this block? It is possible only if you pull this weight downward. So when you pull this weight downward, what will happen? This block will move in horizontal direction with some acceleration. Okay, so what you need to find out in this problem, using Dalembert's principle, determine the acceleration of the system and tension in the rope. Take coefficient of friction between the 40 Newton weight block and the horizontal plane as 0.3. That means in this problem you need to find out how much is the value of horizontal acceleration for this block. That you need to find out. Let the horizontal acceleration for this block is A. This you need to find out, as well as you need to find out tension exerted by this string or this rope. This is a rope or string. How much is the tension exerted by this rope or this string? That you need to find out. Let the tension exerted by this rope is T. So A and T in this problem you need to find out. What is given to you? Weight of this block. Weight of this block is given to you. That is how much? 40 Newton. Coefficient of friction between this block and the rough horizontal surface is also given to you. That is how much? That is 0.3. Also the weight of this small block which we are pulling down in order to give a horizontal acceleration to this bigger block is also given to me, and that weight is how much? That weight is 20 Newton. I need to find out the horizontal acceleration of the bigger block and tension exerted by the rope. How we can find out? For that we need to draw the FBD of both the two blocks, that is the bigger block as well as the smaller block separately, and then we will write down the force equilibrium equation for both bigger block as well as smaller block, and from those force equilibrium equation we will find out the value of acceleration and tension T. So first of all, let us draw the free body diagram of this smaller weight. So how many forces are acting on this smaller weight? So this is your small block. On this small block, weight of the block is acting vertically downward, and that weight is how much? That weight W2 is equal to 20 Newton. the smaller block is connected with the bigger block by this rope. So this rope will exert one tension. This is the direction of the tension force T. Correct? Is the FBD of the smaller block is completed? No. Why? Because we have not considered the inertia force into account using Dalembert's principle. According to this problem, this smaller block is moving down the inclined plane. So the direction of inertia force on this smaller block will be vertically upward. Okay, and what will be its magnitudes? Its magnitude will be mass of the smaller block. Let the mass of the smaller block is m2 into acceleration of the smaller block, that is a. Remember, in this problem, acceleration of both smaller as well as bigger block will be same. Why same? Because both the two blocks are connected by a common string. And due to this, what will happen? Say suppose if you give a vertical displacement of say 2 meter to this smaller block, then this bigger block in this direction will also move by 2 meter. Why? Because common string is connected with both the smaller and the bigger block. So that is why in this problem, for both the two blocks, acceleration will be same. So is there any other forces acting on the smaller block? No. We have drawn all the forces acting on the smaller block. One force is the weight of the block. Another force is the tension force exerted by the rope, and lastly the inertia force that is acting opposite to the direction of motion of the smaller block. Smaller block is moving vertically downward, so the inertia force will act vertically upward and its magnitude is m2a. So let us write down the force equilibrium equation. So for this smaller block, which force equilibrium equation I will write? I will write summation Fy equal to 0, because only the forces are present along y-axis only. So for this summation Fy equal to 0 for this smaller block, I am assuming this side y is positive and this end y is negative. So my force equilibrium equation will be what? It will be T, tension force T acting in vertically upward direction, plus inertia force m2a acting vertically upwards, that is m2a, minus weight of the block acting vertically downward, that is minus 20. No other forces are present, equal to 0. So the force equilibrium equation becomes T plus m2a minus 20 equal to 0. Or we can write T plus m2. How I can write? We know that weight of the smaller block, that is for this block, weight is how much? Weight is W2, and weight is nothing but mass into acceleration due to gravity. If we are talking about for smaller block weight is W2, so mass of the smaller block is M2 into G, or I can write M2 as W2 by G. So in place of M2, replace W2 by G. So we will get T plus W2 by G into A minus 20 equal to 0. Or I can write T is equal to plus 20 minus W2 by G into A. W2 is given in the problem, that is 20 Newton, by G is 9.81 into A. So you will get one equation in terms of tension T and acceleration A, and that equation is equation number 1, that is tension T is equal to 20 minus 2.038 into A. Clear? Similarly, for the bigger block, let us draw its FBD and then we will write down the force equilibrium equation for the bigger block. So let me draw the FBD of the bigger block. So this is your bigger block. Now on this bigger block, how many forces are acting? The first force is weight of the block acting vertically downward. So this is the weight of the block. Let the weight of the block is denoted by W1. So W1 given as 40 Newton. This bigger block is in contact with this horizontal surface. So this horizontal surface will give a reaction to this bigger block in vertically upward direction. This is that reaction force. Let the reaction force is denoted by symbol R. Now this bigger block is given a horizontal acceleration in this direction because we are pulling this smaller block. Then by the help of this pulley and this rope, this bigger block will move in this direction. That means for this bigger block, direction of motion is this direction. This is the direction of motion of the bigger block. Since coefficient of friction is present between the contacting point of bigger block and the horizontal surface, so there will exist a frictional force at the contacting point, and that frictional force will be in the direction opposite to the direction of motion of the bigger block. Bigger block is moving in this direction, so at the contacting point frictional force will act in this direction, that is along negative x direction, and its magnitude is how much? Mu into r. Mu is coefficient of friction at the contacting point of the bigger block and the horizontal surface into normal reaction which the horizontal surface is giving to the bigger block. Now, is the FBD of the bigger block is completed? Not yet, because we have not introduced the inertia force into account. So, according to this problem, the bigger block is moving along positive x direction. So, inertia force will act in negative x direction, that is the direction opposite to the direction of motion of the bigger block, and its magnitude will be how much? M into A. Let M1 denotes mass of the first block into acceleration with which the bigger block is moving. Now is the FBD of my bigger block is completed? Yes. This is the final FBD of bigger block. And this FBD is represented over here also. This is the FBD of the bigger block. Now again for this bigger block, let us write down force equilibrium equation. First of all, let us write down force equilibrium equation along y direction. What we will get? We are assuming that this side y is positive and this side y is negative. What we will get? We will get R minus 40 Newton is equal to 0. No other forces are present along y direction, so we will get R minus 40 equal to 0, or R is equal to how much? 40 Newton. Similarly, let us write down summation Fx equal to 0 for this bigger block. So for this bigger block, summation Fx equal to 0 will be, I am assuming this side x is positive and this side x is negative. So it will be T, tension force T exerted by the string acting in positive x direction, minus coefficient of minus frictional force acting along negative x direction, that is mu r, minus inertia force, it is also acting in negative x direction, so minus m1a is equal to 0, that is T minus mu r, T minus mu r minus m1a equal to 0, or you can write T is equal to mu into r plus m1a m1a, or you can write down T is equal to mu, coefficient of friction given in the problem. That coefficient of friction is 0.3. That coefficient of friction is 0.3 given in the problem. Substitute. So 0.3 into reaction force R. Just now we have calculated reaction force R. R is how much? R is 40 Newton. Substitute. That is 40 plus M1. How I can replace M1? I know that weight of the first block is given by W1, and this W1 is nothing but M1G. So M1 will be how much? W1 by G. So plus M1 is W1 by G into A. Or I can write tension T equal to 0.3 into 40 is how much? 0.3 into 40 is 12 plus W1 given in the problem. This is W1 40 Newton. So 40 by 9.81 is how much? 40 by 9.81 is 4.077 times of A. Let it is equation number 2. Let this be equation number 2. So you have equation 1 as T is equal to 20 minus 2.038 times of A, and equation number 2 as T is equal to 12 plus 4.077 times of A. We have two equations and two unknowns, that is T and A. So just solve equation number 1 and equation number 2. You will get the values of two unknowns, that is acceleration of the entire system and tension present in the rope. So once you solve equation number 1 and equation number 2, finally you will get acceleration of the complete system is how much? It is 1.308 meter per second square, and tension exerted by the rope or string is how much? It is 17.33 Newton. And these are the two unknown quantities that has been asked to you in this problem. In this problem, you need to find out what is the overall acceleration of the system, that is this one, and how much force will be exerted by the rope or the string, that is this one. So this is the complete solution of this problem. I hope you might have understood this problem. It's easy only. Just practice more and more problems from the book. So with this, I end my today's lecture over here, and with this, the entire module of Dalembert's principle is also completed. In the next lecture, we will start with new module. Okay, till then, goodbye, take care. Thank you.